Okay, today I'm teaching you how to do absolute values of graphs. So if I told you f of x was a graph of, oh, I don't know, let's say a strange inside-out teddy bear. No, let's just make it something simple like that. You're going to learn how to take the absolute value of that graph and see what happens to it. There's two ways to do it. There's the absolute value around the outside of it and the absolute value of the inside of it, which affects the x and the y, because the inside of a function is the x part of the function. Basically, that's putting the absolute value like on the inside around the x or around the outside. So anyway, absolute valuing graphs, and then the other thing that's actually harder is learning how to do the reciprocal of a graph. Here's the number 5. What's the reciprocal of it? 1/5. In case you forgot what reciprocal means, it just puts 1 over it. Well, here's a function. Specifically, f of x is the same as y, isn't it? F of x equals blah, 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 blah. So that's like saying y. So when I do this, 1 over it, do you get it's all the y values become 1 over whatever they used to be? If the y value was 5 and I do 1 over it, it's now 1/5. All right, that's the essentials, what I'm going to try to teach you here today. All right, let's clarify. What was this f with the -1? What did f -1 mean? And it's not either one of these. Yes? That meant inverse. This is not about inverses. This is different. Okay, reciprocal of a graph is completely different than the inverse. Do you remember for the inverse, we did the deal where we would reflect it over that line? This is not that. This is different. Okay, moving on to, this is interesting, but we don't frankly have time. So I'm going to talk about that on a different day. All right, so this absolute value graph, which is, by the way, the square root of x squared. I showed you that before. You remember a lot of people, when you're in the midst of solving this, x squared is equal to 16. They go square root, and they say x is 4. And they're wrong. Because what part of this is wrong? Is the square root of 16 4? Yeah. What part was wrong again? Square root of x squared. They thought it's just x, but it's actually absolute value of x. It's so easy to forget, and it's going to come up 4 times on your test this year. It's already come up once. That means it's going to come up 3 more times, where you've got to remember that. Okay, so the square root of x squared is the absolute value of x. Okay, you get that that's this purple graph right here. That is the absolute value graph. Okay, now, what if I take an absolute value of some other function, though? Do you get that the line y equals x would have been right here? That's where y equals x would be. The line y equals x would be this blue line right here. Do you get if I take the line y equals x and then I absolute value that, it changes, and this part of it goes up there. It's because the y values that used to be negative, like let's say this was -1, have now got to be positive because you absolute valued them. So let's see if you process that enough to actually understand this. Here is a parabola that has been shifted down for everybody. Graph your little parabola. Now what if we absolute value that? All the y values, remember we just absolute valued the outside, around the outside. That means y's just got absolute valued. Remember, f of x is like y, right? So the y value just got absolute valued. Do you get that the x values don't care? The y values are what changed. If the y values were positive and you absolute value them, it doesn't do anything different. So in other words, that spot, that spot, that spot, that spot, all those y values were positive. So when the absolute value comes along, it doesn't do anything different. But where the y values were negative, like down here, all of those spots, they had negative y values, it's going to flip up. So can you picture that it'll go down? And then instead of continuing to go down, it's going to flip back up. And there's the rest of it. Think of it this way. This part is where the y values are negative. That part flips up. And now my graph is that and not that anymore. Those are gone because they were negatives and the absolute value caused them to become positive. All right, let's see if you understand what the domain and range of this thing is now that we're done. I know it would have been super easy before, but now that we're done, what's the domain? Doesn't it keep going in both directions forever? Yeah, so its domain is all reals. Could you have written negative infinity, positive infinity? Sure. Range. The range of it is from what? 0 to infinity. Does it touch at 0? Yes. Can you get the absolute value of 0? Yeah, it's 0, so it works. Bracket on the 0. Now, if I'd have just said, here's a function, tell me its domain and range, do you get it in a real pain that sketching it really helped a lot? That's important. Because on the test, we could just give you a function. And you're like, I don't know what its domain and range is. As soon as you make a picture of it, it's easy. Okay, so if you want the domain and range of something, just make a sketch of it. Are you expected to know all functions? No, but there's 6 of them you'd be expected to know. Do you get, I could expect you to know what y equals x squared looks like. Pretty easy, right? Because then I could expect you, based on what I'm teaching you, that you could figure out what that would look like. The absolute value of x squared. Well, first you got to know what x squared is, right? All right, so there's 6 of them. I'm going to write them down for you. You need to know what that looks like. You need to know what this looks like. You need to know what this looks like. What do you think the other 3 are, if you had to guess? Ones you should just kind of know what they look like. Yes? Yes. And that, I'll sketch all of them in a second. And then keep going. There's another one that you guys all know. Yes? Square root. Awesome. Last but not least. Yes? It's not actually the reciprocal function, but 1 over x is called the rational function. But I know you're on the right, think along the right lines, because later today we're going to be doing that reciprocal function. Okay, so you get this one. It looks like just a little line that runs like that. All right, here, what I'm going to do is make the axes all as black lines, and then I will make the graphs all as green lines. That one, that one, that one. I'm not putting arrows on the end just to save time, but you know there would be arrows on the end on all of these, except, now they said that. Okay, maybe I should put arrows in. And then you need asymptotes on this one. Okay. Now the weird thing for the day is that you can absolute value all of those and they'll all look different. Well, actually not all of them will look different. If I absolute value the f of x, which is like absolute valuing the y of the function. Again, there's 2 ways to absolute value. F of x is like this. You can either do the outside, which takes the y, because you know f of x is y, right? And absolute value is that. Or you can do the inside, which is like that. 2 different kinds you have to be ready for. Absolute value in the inside takes the x's and makes all of those come out different because you've absolute valued them. But notice that way doesn't mess with the y's. Okay. So those are the parent graphs. Good with those? So if I said y equals x is your parent function. We just did this one a second ago. What if I do the absolute value of what? Of the y's. Because that's like f of x, right? Couldn't I have written f of x equals x? Yeah, it's the same thing. So then I'm absolute valuing this part. So then do you get, that's the one where it would look like that. Raise your hand if you understand that. Okay, good. Now, what's it going to look like when I do this? F of x is still x. It's the same graph. But now I absolute value the x's. Oh, weird. Would you agree that that means where x was negative has to change? Do you agree that all of these spots here are the spots where x was negative? Weren't they also spots where y was negative? Yeah, but they're spots where x was negative. So they won't be there anymore. So I'm just going to cross them all off. Move this up a little bit, so there. Okay. How about 0? Do you think 0 gets affected when I do that? No. Because the absolute value of 0 is still 0. Okay. So all my x values are gone. Now here's the way you have to think this one through. If I were to put in a 2, do you get, normally you'd get a 2 as your output? You put in an x equals 2, you get a y equals 2, right? When you put in a negative 2 into your function, do you get that it doesn't know you put in a negative 2? Because you absolute value it right away, and it thinks you put in a positive 2. See what I'm saying? So it thinks I put in a positive 2, and it returns the same value as if I did, which is a 2. Final answer? It ends up looking exactly the same as the other one. Is that the case all the time? No, for sure not. Let me show you a little more complicated situation. Remember, the key here is I erased all the stuff that it used to have for x, because when I put in negative numbers for x, it's like I'm putting in positive numbers. So what it did is it copied whatever is over here and put it over there. All right, so do you agree there's probably some function that looks like that? We're going to call it f of x. Your challenge would be, if this was f of x, 2 things today. One, we're going to be absolute valuing the inside of it and seeing what that looks like. The outside of it, seeing what that looks like. And we're going to be doing 1 over it. That one's called the what? Reciprocal. So there's 3 things you have to learn. I've just been talking about absolute values so far. So let's do, what would absolute value of x this way look like? Everybody draw what you think the answer should be. Hint, I'd draw the original one first, and then I would just take and move some parts of it. So the way I want you to think this through is this. Did I just absolute value the x's or the y's? Isn't f of x the same as y? So didn't I absolute value the y's? That means anywhere where there was a y value that was negative, which is this little zone and this little zone, those zones had y's that were negative. Those, then, when you absolute value something, it becomes positive, right? Do you get that those zones then change to being above the line instead? Scribbling this out, it's no longer there. There's my final answer. I'll draw it all in green. Raise your hand if you had that one right. Okay, awesome. Now this next one is going to look totally different. That was absolute valuing the outside. Now I'm going to absolute value the inside. So you get, I just made all the x's that were negative change. The x's that were negative have to change now because you just actually valued the x's. Where was x negative? Would you agree that all the spots here that I just made dots on, those all have x's that are negative, right? Okay. So all of those need to go away. I'm going to get out my surgical eraser. There we go. I can be really, really careful. And they're all gone. Notice this is going to be different than the other one. You know what I mean? The one we did before, it just looked, they would look the same when they were done. Now, remember me saying that when you put in like a 2, you got an output. And now when I put in a negative 2, it's going to think I put in a positive 2. The final answer then is the golden arches, except they're blue in this case. What just happened? Everything that was over here got copied to over there. Because let's say I put in 3. Let's say that's the spot 3. What does the output say? 0. When I put in negative 3, do you get that it thinks I put in positive 3? Therefore, the output's 0. Now, I know some of you aren't understanding this, and it's okay. You just need to learn the shortcut, which is this. When I give you a graph, like this, if you're absolute valuing the outside, that's the y stuff, right? So wherever y was negative, which is only this little part right here, only that part needs to change, and it needs to go up instead of down. Most people can get that one right. Do you get that there's nothing down here anymore? On that kind of graph, everything that was down there goes up. Okay, so here's the shortcut. Again, I've explained why, but I've explained it enough times that if you were going to get it, you probably would have. So if you absolute value the inside, then wherever the x's were negative, they go away. Do you get all of those spots are where x's were negative? And they go away. And then you just have to recopy what you have here on the other side. And the reason, again, is because when you put in a negative number into your function, it thinks you put in a positive number. And so it gives the answer like you were over there. If you don't get it, at a minimum, understand that on this kind, what was the first step? Erase everything where x was negative. And then take whatever's over here and reflect it over there. Okay? All right. Here's your final test. Would you agree that would be a parabola except shifted right and down a little bit? Okay. Would you please find the 2 ways you could do this? If this is f of x, what is f of x with the absolute values around the outside? And what is f of x with the absolute values on just the x's? They look quite different. Try to get both answers. And I'm going to pause for a second while you give this a shot. Turn and show the kid next to you. Once you're done, wait till they're ready too. So I'm going to do the green one, which is absolute values around the outside. So far, I would start with just the parent, really. Just whenever you do these, start with the parent one. Then think about what changed. The y's that were negative had to go positive. So this little part's gone, and it goes up here. Raise your hand if you had that part right. Okay, awesome. The harder part to do, I think, is the other kind. I'll do it in black. On this kind, what changes? The stuff that has x's that were negative. That's this part. This part's gone. In fact, I'm going to actually erase it because it'll get really messy over there if I don't. So that part is gone. And then I copy what was over there. It's like this. Raise your hand if you had that one right. Okay. Any questions about that kind? Okay. Then we now need to learn something completely different, but we're going to use the same function. And we're going to do something called, have you figured it out yet? It's not inverse, it's reciprocal. We're going to learn how to do the reciprocal of this graph. Okay. So this is f of x. What's the reciprocal? Don't overthink it. It's 1 over f of x. And to clarify, f of x is like y, right? So 1 over f of x is where you take 1 over every y value. Think of this as a whole bunch of points, right? There's a point here, there's a point here, there's a point here, there's a point here, 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 here. And they all have names, like what comma what, you know what I mean? And notice, I'm not going to touch their x's. And I'm going to take all their y's and make them into 1 over whatever it used to be. Okay, so let's just name these points. Would you agree that one's 0, 0? This one, let's say that it's 2 comma negative 2. Let's say that this is 4 comma 0. Let's say this is 6 comma 3. Let's say that this is negative 4 comma 3. And I could be off from exactly what these are. I'm just kind of guessing what each point is. And now I'm going to do one more. Let's say that this is 7 comma 6. And this is at negative 5 comma 6. If you have trouble with these, some of you will, because this is tricky, that all you have to do is make this list like this. Take all the parent points, and then all the x's are going to stay the same, and all the y's are just going to become 1 over whatever the y was. So, if I make myself a big old list here, negative 5, 6. And I'm going to put them in an xy chart, though, so I'm going to have a line in between them. So, x, y, negative 5, 6, negative 4, 3, 0, 0, 2, negative 2, 4, 0, 6, 3, 7, 6. Do you get, I could even make up more points if I needed to, you know? Like if I really got confused where, like what's happening in this area of the graph. You'll see what I mean in a minute. You could make more points up. Really, you could even just make them up because I'm not going to be checking you for exactly, did you go to 1/6 instead of like 1/7 on the graph? It's really hard for me to tell anyway. So I kind of made up these numbers. You could kind of make up numbers that are, you know, reasonable. Now, what am I going to do to all the y's? Make them into 1 over what they were. So my new y, I'm going to call it y prime, is going to be 1/6, 1/3. What's 1 over 0? It's not 0. What's 1 over 0? Undefined. What the heck does that mean? That means there's an asymptote there. That's one of the reasons these graphs get weird. It's because you can't put 1 over 0, can you? No, you can't. Okay, I'm going to put 1 over this, so it's 1 over negative 2 or negative 1/2. Whoa, it hit 0 again. Undefined again. And then 3, 1 over 3, and then 6, 1 over 6. Now if I graph all those points, you will see, well, first of all, I'm going to put in these asymptote lines. At 0, there was an asymptote. Think about it. Why is there an asymptote here? Because the graph was at 0, and there's no such thing as 1 over 0. So we can't have anything there. Same with this spot. Now, every other point just has a point that goes with it. So this point, negative 5 comma 6, is now negative 5 comma 1/6. 1/6, that's really small. Yeah, you're right. So I'm going to put this dot down here at negative 5 comma 1/6. The next one's at negative 4 comma 1/3. Well, 1/3 is higher than 1/6 is. So this is up just a little bit. The next point I have is 2 negative 2, which is now going to become 2 negative 1/2. So that is about here. The next point I have is 6 comma 3, and that's turned into 6 comma 1/3. 6 comma 1/3 is like, oh, this is kind of in the way. Let me move this down here. 6 comma 1/3 is like right there. And the next one's 7 comma 1/6. 7 comma 1/6, up a little bit. If you can just look at the green dots, it's not coming together really well yet. Yes? You're right. You're right. Thank you. You're right. This one's a little higher. This one's a little lower. Thank you. Okay. Now, let me fill in the missing pieces. Just to clarify. Do you get, I could make up another point, like in here? Do you agree that it's potentially possible that that would be the point 3 comma negative 1? Does that seem possibly believable? I'm going to put another point on my graph, because you're going to have to do this too. You're going to be like, I don't see where it goes. Well, what does 3 comma negative 1 turn into? Well, what's special about negative 1 is that when you put 1 over it, it stays the same. It's negative 1 over 1, which is negative 1. So this point stays the same. That makes that a very special point. This point, I'll make it red with green inside it. Christmassy point. That point right there is very special because it's the only spot we found so far where 1 over that spot is exactly the same. Does anybody want to generalize that? As in, hey, whenever this happens, it'll always be the same. The 1 over the function is always going to be the same. Come on, use that big brain. What happened? Was it just pure luck that it ended up being in the same spot? No. What was special about the y value? It was 1. Do you get that 1 over 1 will always be the same? So those spots become really important. This spot, wherever it hit 1 on the original graph, that spot would be very important because it would go through that spot. All right, final answer. Oh, I'd better do it in a different color than blue. That would be a really bad idea. I'm going to make it in black. And it gets closer and closer and never touches the asymptotes. You know that about asymptotes, don't you? Okay. This one. Where's that, again, special spot? Wherever it would have hit 1. I'm going to say it would have been right there. Then the new function goes through that. Red and green dot. And it goes like this. Closer and closer, never hits the asymptote. Would there be one more special place? Yes, right here. And now, connecting dots, using black to do my inverse. I'm going to go through this, and then I'm going to get closer and closer to the asymptote and never touch it. Same over here. Now, I went meticulously slow on that one, and you could too. Do you get I just could have gotten more dots, more and more dots, and then make 1 over their y value, and then just make more and more and more dots? If you make it ludicrous enough that when you're all done, you just have a whole bunch of dots, it'll become really obvious where to connect said dots. You're like, well, I guess it goes like this. You know what I mean? Just, you have to make enough dots and you can see where it goes. But I'm hoping in a second here, after I generalize here, if I just generally give you the idea, that you'll be able to go and do these a lot faster than what I just showed you. Again, this is not super easy. All right, so going back to this one, I'm going to go back in time. I'm going to go back until it was just the original thing. And you remember how I made the list of all the points and stuff? You don't actually have to do all of that. I'm giving you that as the XY chart's your friend. You can always use that if you want to. But watch me do this the fast way now. Do you remember the asymptote spots? That's when the function was equal to 0, and you can't do 1 over that, right? So here and here, I missed them a little bit. I'm going to move them over. My alignment's off. There's asymptotes there. Then I'm going to take wherever I feel like the function is equal to 1, which I feel like is here and here. Sometimes they'll even have it labeled on the graph. And there were all the spots where it was either 1 or -1. Do you get how those are the spots that are going to be on the new graph? Because 1 over 1 is 1. Those are the spots that'll retain, they'll stay. Then, how about this? If this is, would you agree this has a negative y? Would you agree that that spot is a negative y? And by putting 1 over it, it's still going to be negative. These will never cross over those lines because they can't. Because that would be a negative turning into a positive. By putting 1 over it, you can't do that. So they'll never go across that line. So do you get if it has to get close to this, and it has to get close to this, and it has to go like that. Can't go across the line. It can't like wander up in here. Can't do that because you can't go across the line. All right. How about this? Do you get that this function has to get closer and closer to this asymptote? And I hope you can see that it would go off like this because it can't go across that line. Because it can't turn itself negative. Why can't it turn itself negative? Because 1 over something never turns it negative. If it was negative, it stays negative. All right, and last but not least, there we go. So it's almost like the x-axis becomes an asymptote too. It can't touch that. These are MC Hammer's favorite problems. There's all kinds of places where you can't touch this. Okay. If you got that, I'm going to give you a fairly simple one. There. Do the inverse? No, not the inverse. What's this called again? The reciprocal of that red little function. Let's actually make it touch 0 here. That's fine. That'll make it a little bit easier. There. Sketch what you think the reciprocal looks like. You put it on the same graph. Just do it in a different color, please. Okay, so change colors. I'm going to pause. We give this a try. All right. If you're like a step person, okay, what's step 1? You find the asymptotes are. Where did my red function touch 0? There and there. Raise your hands if you had asymptotes in the right spot. Okay, good. Now, I hope you thought of this as going up higher than 1. So at some point you figured it was at 1. I don't know exactly where. 12-minute warning. I don't know exactly where, but I'm going to say that that's where 1 was. You could have picked somewhere else as long as you were kind of above 0. Could a kid have even said that that was 1? Well, again, our problems will typically be labeled exactly where 1 would be. But yeah, you could have, and then that would have changed how it looks. But then you get my new answer, which I'm going to make in a different color. I'm going to use blue. Would have to get close to that asymptote. That thing acts like an asymptote, so it can't touch that. And there we go. Raise your hand if you had that part right. Now, a lot of people then get it wrong because of one little thing. What part didn't we deal with? That little part over there. You can't just ignore that. That needs to have a 1 over thing also. So, will it turn positive? No, those are negative y's. When you do 1 over them, they stay negative. What's the one important spot on that? Wherever you thought 1 was. If I think this is where 1 is, then that's the one spot that'll stay the same. And now it has to get close to, think of this as kind of like an asymptote here. It has to get close to both asymptotes. So how would you do that? Like that. Except technically it doesn't go forever because I didn't put arrows on the end of it. So I should cut it off like that. That little tag end gets so many people on the test. If you had to, make up 3 points on here. Make up a point here, here, here. That's the special one that when I went over it stays the same, right? And then if you just do inverses of them, this would go down here, this will go down here, this is up here, and you connect your dots. All right, I'm going to do one more. Ready? So that's my original function. What would its, and here, let's all agree on where 1 is. Let's say 1's right there, and there, and there, and here. Those spots are all going to be 1. That way our graphs will look similar. Now remember, put in the asymptotes. Act like the x-axis is an asymptote. And draw for me the reciprocal of this function. Yes, sir. Yes, sir. Now, I know somebody's going to say, is it okay if I actually just make a whole bunch of points? Yes, absolutely. You can make a whole bunch of points. And you take their y values and you make them 1 over whatever they were. That's totally okay. And when you get stuck in an area on the graph, like, oh, I'm not sure how to do this area of the graph, make a point in that area of the graph and make that point move to where its 1 over spot is. All right, I hope you realized there were asymptotes here. If nothing else, because it touches 0. Just keep it that simple. The function is 0. If it's 1 over 0, it can't exist. Closer and closer, never touch. Can't curl across that line, otherwise I'd be turning negative. Back up again. Raise your hand if you had a U kind of in that section. Good job. Then, in this little zone, aren't I positive? Yeah, I got to stay positive. Get close to the asymptote, never touch it. And that kind of does the same thing down here, because it can't go negative. Last but not least, this little zone. Well, We agreed that that blue spot was going to be 1, so it's there. Now, as I move, oh, this is really, it's really small. I'm going to have to blow it up a little bit. I'm going to make it a little bit bigger. That's the key spot. There's a lot of common mistakes here. People will go like this. Graph isn't even defined to the left of it. If I was going to pick a few spots, I'd pick another spot that's like maybe there. See what I'm saying? And that's the spot I'm confused in this area. So I'm going to pick that spot, and I'm going to say it's at like -4, -1. Doesn't have to be perfect, but I know, wait a minute, it can't be -1 though. The y, that would be this spot. So this spot here is like -3, -1/2. Well, what's special about this spot is it stays the same. So, okay, I'll make sure to go through this spot. But this spot, the y value of it had to go 1 over this, 1 over 1/2 turns into 2. So it turns into -2 is my new y of it. -3, -2. So that's down this way. So that goes that way. And technically, you could keep drawing it as long as you don't touch the asymptote line. So you get how that one little area could be confusing. How did I fix it? I made a little point on my f of x, and then I just had to figure out what was 1 over the y value going to be. And since I had this little point was at less than 1, I said it was -1/2, then 1 over that was -2. And I could tell which way to go. Okay, that's all the new stuff. Now, your homework is going to be like that, and then tomorrow we get to practice it again for review, and then Wednesday is the test. The hard part is those reciprocal graphs, the one that we just did. The easy part is those absolute value ones. They're pretty easy, really. All right, I'm going to summarize the absolute value ones real quick. If I had a picture like this, and I was supposed to do the kind where it does, if this is f of x, if I do the outside kind, like absolute values around that, all the y's that were negative can't be anymore, and it would look like that. Remember that? Okay, and what if I do the inside? If I do insides, it's the stuff that was where x was negative goes away. That little zone right there is where x's were negative. That goes away. And the other side gets copied over. So it's like a reflection. That's the kind where it's absolute valuing the insides. And then last but not least, the one we just did a second ago. I'm going to do it at light speed here. Asymptote, asymptote. I'm going to say this is where it hits 1 and -1. And it goes like that. And this little zone's tricky. I got to get close to this asymptote and close to that asymptote. There. Oh, wait, and then the blue part. It's another spot where it's -1 right there. And it has to get close to both asymptotes. That's like an asymptote, remember. And that's actually an asymptote. And there we go. There. That's the 1 over graph. That's the not inverse, reciprocal. Okay. That sums it all up. Now let's look at the homework together. There we go. This is the first slide. Now this is reminding you that you might be asked to just do that. Don't forget, you know the parent function. It's x squared. It's a parabola that's moved right to, what's that 4 doing? Couldn't I put that 4 at the end? Yeah, so that's actually an up 4. And what's this negative in front? A reflection. And if you're like, oh, crap, we have to do all of that? Not really. You know what you really have to do? How can you graph anything? XY chart. You can always just go back to the XY chart and see what it looks like. Put in 0, and I get negative 2 squared is 2. 4 minus 2 is 2. 0, comma 2 is on my graph. Got to go through that. You can always graph them that way. Then, this graph. Once you got the parent one, it's going to be easy. You're just going to do the absolute value around the outside of it, which means all the y values, wherever there were y values on it, all those y values are going to change. Now, there's not enough graphs here to do all of these, so I'm going to have you just do the top one. So you may skip that one. Again, it'd be a great practice problem for a review for the tests. Because remember, tomorrow's homework is there isn't any homework. Maybe you should go back and do this one. If your grades have not been as high as you wanted, if you keep doing what you're doing, you're going to stay the same. If you're not as high as you wanted, this is the thing that's really going to make a big difference. Take an extra, however long this is going to take, and go back and do all the problems we skipped. All right. So this one, this is just describing what happened, like 2 to the left and down 3. Okay, so these are super easy. I want you to do all 3 of them. They're really not that hard. Okay, don't overthink this. Describing it is just saying which way it went. Okay, do the same thing for this. Man, what's so hard about it is that we've absolute valued it here. So when you absolute value it, it's going to look different. Better make a sketch of it. Okay, so just a reminder here, it's not quite as easy as I thought. It is left 2 and down 3. That part's easy. But these you better make a sketch of to figure out whether it's really going left 3 and down, sorry, left 2 and down 3. Because once you have a sketch of what this thing looks like, it might be going somewhere else. All right, I'm going to have you skip this whole page, the yellow page. And you need to do that problem, that one. And I should probably do this one also. So skipping C and E. This would be a great review problem, though. E would be. You can skip the whole rest of the worksheet. Okay, and this is definitely a skip. All right, if you need to get what we actually did, come on back up here and talk to me or watch the video. Have a great day.